Title of the experiment 8:1 multiplexer. Today's session we are going to discuss how to simulate 8:1 multiplexer using quarters 2. First click on the quarters 2, open quarters 2 window is going to open, and click on file. After you cancel this window, then click on file, new project, check the details and set the path, give the directory name, then the folder name, give the file name as the folder name here. ADE, you can give the experiment name itself as a file name. You can give your own name. I have given ADE mux as the folder name. Click on open. So directory name is given, give the name of the project, the same name has to be given, ADE mux. Same thing is chosen as a design file name, then give the file name again the same, ADE mux. Next, then check these details, cyclone, family name, package, all that. Click on finish. Now create a new file, new, select VHDL file, say OK. Now there is a window open where you can write the code, VHDL code, type the VHDL code to simulate 8:1 multiplexer. So here program is typed. You can see the entity name. Entity name must be same as the file name, ADE mux, the same file name. While terminating the entity block, end followed by entity name, ADE mux. Same thing has to be changed in architecture block. Architecture name of entity name, ADE mux. Check the program. I is given as an input for the range 7 down to 0. That means a 8-bit data. And select is a range of 3 bits. 3-bit data. But Z out is a single bit data. So 8 cross 1 multiplexer, 8 input, and at the input side we have 8 pins, and at the output we have only 1. Now save this. Now compile the program. Wait for a while. So once you click on the compile, you generate the compilation report. If there are any errors generated, go back and change the program, again save it, again you have to compile. If there are no errors, you will get compilation is successful. So full compilation was successful. Say OK. Now you have to create the vector waveform file. Click on file. So once you finish compiling, next we have to go for waveform. We need to generate the waveform. So we are supposed to create file new. This time you have to choose vector waveform file. Click on OK. So waveform file is generated now. Edit, end time has to be set. You can give some value, time period for end time, set 10 nanoseconds. Click on OK. Now next step, you need to insert the node bus. Node folder has to be generated. Take the list of the inputs and outputs. Select all the inputs and outputs. Then click on OK. So the required number of inputs and outputs have taken multiple items. Say OK now. So input I and select is done. You need to give the value. Right click, clock, set the period as some value, say 1 nanosecond. Say OK. Same way, click on select. Right click, value, then choose clock. This time you can give 2 nanoseconds. Say OK now. Select is also done. You need to save this. Save the waveform file. Save. Some name should be given here, ADE mux and waveform. Name can be given. I'm using the same name, so ADE mux waveform. VWF vector waveform is done now. Check that. Again, I'm going to set edit end time for the waveform file. Edit. So click on edit. Then end time. I'll do the same thing, 10 nanoseconds. Say OK now. Next, assignments. Settings. To check for functional block. Say OK now. Next, click on processing. Then generate functional simulation netlist. Functional simulation netlist is generated successfully. Next step, processing. Start compilation. Once again, you compile it. Wait for a while. Compilation report is generated along with the window. Compilation completed successfully. So if there are no errors, you get the successful compilation output. So what is the next step? Full compilation was successful now. Next step, processing. Next you are supposed to start compilation and simulation together. So simulating the code and the waveform to be generated. Wait for a while. Once simulation report is done, you get the waveform, compile and simulation is successfully done. See the waveform now. So when I is 0, select is 0, Z out is 0. When I is high, 255 is high. That time Z out is high. We can verify these waveforms with respect to the truth table. So Z out is either logic 0 or logic 1. Whereas select based on the cases. When it is 0, 0, 0, I of 0 is selected. If it is 0, 0, 1, we have to select I of 1. If it is 0, 0, 0, 1, 0, we select I of 2, so on. When 1, 1, 1, we select I of 7. So verify the input and output waveforms with respect to the truth table. Fine. So both the input and the output waveforms are verified here. If it is necessary, we can also check each and every bits I of 0, I of 1, so on. This is the output obtained. Thank you.